we're going to take a look at polynomial division, and we're going to see two different types of division. One is the long division that you're probably a little more familiar with, and the second one is synthetic division, which only works in certain cases, but it's a really quick, easy way to do some of these division problems. We're also going to connect the polynomial division with zeros or x-intercepts of our function. So I want to go ahead and start with some vocabulary terms. So I've got a simple problem here. 15 divided by 5 is equal to 3. So if I were to do this as a division problem, 15 into 5 goes 3 times. We can identify each of the pieces of this division statement using some vocabulary terms. So we call 5 the divisor. 3 is the quotient, which would be related to the answer. And 15 is called the dividend. We actually don't use the word dividend very much. So more importantly, I want you to pay attention to divisor and quotient. Okay, so 5, the number that goes on the outside here, is my divisor. And 3 is the quotient. There's no remainder here because it goes in evenly. Let's take a look at the next example. So for this one, we've got 15 divided by 7. So if I were to do this in, sort of long division, I would go 7 into 15. It goes 2 times. I multiply back. 2 times 7 is 14. And then subtract, and I get 1. So I can say that it's equal to 2 remainder 1. So as I look at this and identify these different vocabulary terms, 15 is the dividend. I'm not super concerned with that in terms of vocab. 7 is my divisor. 2 is my quotient. And 1 is my remainder. 2 remainder 1 gives me what I get from the long division, but more importantly, I can use it to get back to 15. So when I go to part B here, I can go ahead and think about how I could write this in its original form. Let's do this with a calculator. So if I were to, in my calculator, do 15 divided by 7, it doesn't give me 2 remainder 1. It gives me 2.14285, a bunch of decimals. So it gives me about 2.14. If I were to do it in the form that we've got here in part B, and I write 15 divided by 7, and this is going to be similar to the answer in that calculator, is going to be my quotient 2 plus remainder 1 over divisor 7. Let's try that in the calculator. So it's 2 plus 1 divided by 7. And that gives me the same exact answer. So if I want to recreate the statement using the values that I get as my answer, that quotient and remainder, I write it in this fractional form. For just good old numbers, we don't need the plus sign there. We can just write 2 and 1/7. But for polynomials, which we're going to switch over to, we do need that plus sign in the middle. Okay, so let's go ahead and move on into a division with polynomials. So in this case, we're dividing it by x. I'm going to write my long division, x into, so x is my divisor, x into, and I want to make sure I've got a placeholder for each of my terms. So I have a degree 3 term, I have a degree 2 term, but what's missing is this degree x term, or a degree 1 term, an x term, degree 1. So I'm going to go ahead and put that placeholder in, and I've got 0 x's, and for the constant, I've got 18. Let's go ahead and do our division. I'm going to do this first step in red here. So I compare first terms with first terms, and I'm doing division, which undoes multiplication. So I'm really thinking this through as multiplication. What do I need to multiply x by to get to x cubed? Well, I would need to multiply it by x squared. I'm going to multiply that through. X squared times x cubed is x cubed, and now I'm going to subtract, and I get 0. I'm going to bring down my next term, so minus 5x squared. I need to write smaller. And now I'm going to go from, again, I'm going to do this guy in green. I'm going to run out of colors too. I'm going to go from first terms to first terms. Now, how do I get from an x to a 5x squared negative? I need a negative 5, and I need another x, so negative 5x. Now I'm going to multiply this guy through. So I multiply that through, I get negative 5x squared. I'm going to subtract. When I subtract, I actually end up adding, right? These two negatives become a positive, and I get 0. I can bring the next guy down, which is plus 0x. It does not go into 0x. So I can go ahead and bring the 18 down, plus 18. X also doesn't go into 18. I would need an x term there. So what I end up with is a remainder. So we don't write, I could write like R18, but that's not really meaningful when it comes, I'll put it up here, R18, when it comes to polynomials. So let's go ahead and write our answer. I'm going to write it in blue. Actually, let's circle the answers here. So first of all, this right here is my quotient. This is my remainder, just like it was with our numbers. So my quotient, x squared minus 5x, remainder is 18. And now I want to write it in the form quotient plus remainder over divisor. I know that this is going to be equivalent to the original division problem. So I'm going to write my quotient, x squared minus 5x, plus remainder, 18, over divisor, which is x. If I look at this 2 1/7, notice how I've got that 7 that still needed to divide into the 1. It just wouldn't go. Same thing over here. I had an x that needed to divide into the 18. It just wouldn't go. So this is that form, quotient plus remainder over divisor. Okay, let's do another one. So in this next one, I'm dividing by x minus 3. So x minus 3 is my divisor that goes out front. My dividend, I've got degree 2, degree 1, degree 0, no missing terms. So 4x squared plus 3x minus 1. Okay, here we go. I'm going to compare first terms with first terms. So I need to go from an x to a 4x squared. For the coefficient, I need a 4. For the variable, I've got 1x. I need to multiply it through by another x. Now I multiply this guy through. So I multiply it through, I need to multiply it by the x and the negative 3. So 4x times x is 4x squared. 4x times negative 3 is negative 12x. I'm going to subtract these. When I subtract, it really changes my sign. So I'm going to subtract. Subtracting a negative changes that to a positive. Okay, what do we get? The first one goes away. It always will if you're doing this correctly. When I add my x terms together, 3x now plus 12x is 15x. Bring the next term down, minus 1. And I play the game again. So now I want to go from an x to a 15x. What do I need to multiply by? The x is already matched. I need to multiply by a positive 15. These are polynomials, so the sign writing it down in front is important. Now I'm going to multiply this 15 through. 15 times x is 15x. 15 times negative 3 is negative 15. I'm going to subtract, which is really just changing the signs on both of those. So the 15s go away, which was exactly my plan. And the negative 1 plus 15 gives me plus 14. X does not go into 14. There are no x's in there. So this turns out to be my remainder. So remainder 14. Let's go ahead and write our answer, quotient, and then remainder. I'll go back to my blue pen. So my quotient is all of this right here, 4x plus 15, and my remainder is 14. Next, we want to write it in the form quotient. So we want to get quotient plus remainder over divisor. So my quotient is 4x plus 15 plus my remainder is 14 over my divisor. My divisor is that x minus 3 over x minus 3. Okay, here comes another one. Again, no missing terms, which is really nice. I put my divisor of x plus 4 out in front. And then I've got 2x squared plus 11x plus 12. I start by comparing first terms to first terms. I compare my x to my 2x squared. The coefficients don't match. I need to multiply by a 2 to get to that 2x squared. I also need to multiply by another x. Let's go ahead and multiply this through. 2x times x is 2x squared. Those should match. And then 2x times the 4 is plus 8x. I need to subtract these, so I'm changing the signs in front of both of those. And this is going to give me 2x minus 2x squared, that's 0. And then 11x minus 8x, that's going to be 3x. Bring down the next term, plus 12. Now we do it again. That first term compared to this first term. What am I missing to go from an x to a 3x? I'm missing a positive 3, so plus 3. I need to multiply this through, so 3 times the x is 3x. 3 times the 4 is 12, plus 12. I need to subtract, which is changing signs. They're both positive, so they both change to negative. And now I subtract, 3x's go away. 2 minus 12, that's going to be minus 10. So remainder minus 10, negative 10. Okay, here comes the answer. So the quotient is the value on top of the division bar. So that's going to be 2x plus 3. My remainder is negative 10. Next, I want to write it in the form quotient plus remainder over divisor. So that's going to be 2x plus 3 is equal to my remainder, not equal, plus remainder of negative 10 over my divisor, which was x plus 4. Okay. Next, so I've got another division here. I take a look at those degrees in my dividend. So I've got 3, 1, and 0. So I need to go ahead and sneak in a 0x squared. So I've got a 2x plus 2 on the outside. I'm going to divide that into 2x cubed. I don't have any x squared, so plus 0x squared minus 4x plus 1. And I can go ahead and do my division. Let me erase. I'm going to erase this guy so I've got some more room. Okay, I'm going to do my division. I'll do it in green again like I did the last time. That works nice. So I'm comparing first terms with first terms. The 2's already match, but I need to get from an x to an x cubed. So I need to multiply by an x squared. I'm going to multiply this through. X squared times 2x is 2x cubed. Those match, perfect. And then x squared times 2 is plus 2x squared. I'm going to subtract. So I change the signs on both of these. They both change to negative. And that's going to give me the 2x cubes go away. 0x squared minus 2x squared is minus 2x squared. Bring down the 4x, minus 4x. And then I do this again. I'm going to compare that 2x to negative 2x squared. So I need a negative. And to go from x to x squared, I need an x. So let's multiply this guy through. So x times 2x is negative 2x squared. Negative x times 2 is negative 2x. I'm going to subtract, which is changing my signs. So those both change to plus now. And let's go ahead and combine these. The 2x squareds go away. Negative 4x plus 2x, that becomes negative 2x. Bring down the 1. Now I've got to go from a 2x to a negative 2x. The x's match, so I just need a negative, really a negative 1. And I'm going to multiply that negative 1 through. So negative 1 times 2x is negative 2x. Perfect. Negative 1 times 2 is negative 2. I need to subtract those, which for polynomials means we're changing the signs. They both change to plus. And then I combine them. I'm almost done. Good thing because I'm out of room. 2x's go away and I've got a 3. 2x cannot go into 3. There's no x there. So this is my remainder. So remainder 3. So I'm ready to go ahead and put my quotient. and remainder. There's my quotient and my remainder. So quotient is x squared minus x minus 1, and my remainder is 3. So as I write this in terms of quotient plus remainder over divisor, it is x squared minus x minus 1 plus my remainder of 3 over my divisor of 2x plus 2. Okay, and there's that. Okay, next we're going to take a look at synthetic division. If you haven't done it before, it's, well, I think it's fun, which maybe isn't saying much because I really enjoy math, but I think it's kind of fun. You just need to get used to the pattern, and it's a really quick way to divide, except your divisors have to be in a particular form. They either have to be x plus something, I'm just going to use c as a placeholder, or x minus something, so x minus c. So as we go back up through the examples that we just did, I cannot do number 4 using synthetic division. Let's see. Here's the divisor x plus 4. I could have used synthetic division for number 3. Continuing to go up here, I could have used x minus 3. I could have used synthetic division for number 2. And number 1, I can think of this as x plus 0. So I could have used synthetic division for number 1. Polynomial division is pretty tedious. If you end up with a divisor of x plus or minus something, I encourage you to use synthetic division instead, even if the instructions say use polynomial division. Let's only save polynomial division if we absolutely need it. Okay, so if you look at this first example, sure enough, I can use synthetic division. Synthetic division uses the idea of zeros. So if I were to grab a 0 out of this factor x minus 3, x would need to be a positive 3 to make that a 0. So we take that value 3 and we put it out in front of a division bar that covers 2 lines turned upside down. The nice thing about synthetic division is it only uses the coefficients. It doesn't use any x's. So I'm just going to keep track of my degrees here. So I'm going to go degree 2, 1, and 0 for my columns. And as I write these in, I'm going to use the coefficients from those terms. So I've got 4, 3, and negative 1. Okay, I'm ready to do my synthetic division. As I move down through the synthetic division, I add 4 plus nothing is 4. As I move up through, I'm going to multiply by that 0. So each time I move diagonally, I'm going to multiply by my 0, which would be 3. 4 times 3 is 12. As I move down, I add. So 3 plus 12 is 15. As I move up diagonally, I multiply. 15 times 3 is 45. And then finally, that one last time, I'm going to move down. Negative 1 plus 45 is 44. Now we've got to interpret this, right? This should mean something. So as I interpret this guy, this right here is my remainder. Remember, I was keeping track of those degrees. 3 came from a degree 1, that was x minus 3. So I just divided a degree 2 by a degree 1, which means that this drops to degree 1. So the 4, my coefficient, represents an x term, and the 15 would drop to degree 0, so that represents just a constant. So I've got my remainder there. My quotient is this guy. Okay, so what does it say? Oh, express your answer in the form quotient plus remainder over divisor. So if I write my answer out then, let me go back to my blue pen. So my answer, quotient plus remainder over divisor. My quotient comes from the bottom, 4x plus 15, plus my remainder was 44, and my divisor was that x minus 3. So that's my answer there. Okay, let's go to part B. So in part B, I want to use synthetic division again. I need to find what would be a 0 from the divisor. Well, for this one, I would need a -4. So I'm going to divide a -4 in. Let's go ahead and set up the synthetic division. -4 goes on the outside. On the inside, I want my dividend, and I'm going to keep track of the degrees. Degree 2, 1, and 0, 2, 1, and 0. Those coefficients are all I need. So I've got a coefficient of 2, a coefficient of 11, and that constant was 12. Remember, as you move down through the synthetic division, you're adding. 2 plus nothing is 2. As I move up, this time I'm multiplying by that 0, possible 0, which would be -4. 2 times -4 is -8. I move down, I add. 11 minus 8 is 3. And as I move up, I'm going to multiply by that -4. So 3 times -4 is -12. I add those together and I get 0. So my remainder this time is equal to 0. My quotient, I was degree 2. So when I'm looking at these degrees, whenever I do this division, my degrees drop by 1. So now that 2 is going to be in the degree 1 spot. So 2x, 3 is now in the constant spot. So you always just go from the highest degree and then you just subtract 1 from it. So now it's going to be a 2x. If that was a cubed, in your quotient it would be squared. So just 1 less. Let's go ahead and write this in the form that we were asked. So quotient plus remainder over divisor. Well, my remainder is 0, so I actually don't need a remainder this time. So just my quotient, 2x plus 3. I want to put this polynomial, my dividend, into Desmos, and I can show you why we are calling that -4 a possible 0. I keep saying that, but I haven't actually shown it to you yet. So I'm going to graph 2x squared plus 11x plus 12. Okay, so f of x or y, whoops, let me get myself in that box. So f of x or y is equal to 2x squared plus 11x plus 12. And I notice that I'm in a kind of a funky zoom here. So I'm going to go into my wrench settings, and I'm going to change this so it goes from -10 to 10. Do the same thing here, -10 to 10. Okay, take a look. As I'm looking at my zeros, there's one of them. It's -4. So if it is true that that 0 that I'm dividing in does give me a remainder 0, that means it is an x-intercept. The other one is -1.5. So this is not just a possible 0, this one is a 0, and it's all because that remainder is 0. The other thing that we can translate this into is evaluating my function. So if my function is that dividend, 2x squared plus 11x plus 12, my remainder is actually the value of f of -4. So f of -4 is equal to 0. Let's put that in. F of -4. And sure enough, it's 0. Let's see if that also works with the last example. In the last example, we had a remainder of 44. This time it was 4x squared plus 3x minus 1. Let's change this. 4x squared plus 3x minus 1. Let me make sure that was right. 4x squared plus 3x minus 1. Okay, good. Okay, so here it is. I want to evaluate this at the number that I used as the possible 0, and it turned out it wasn't a 0. I divided in that 3. So this 3 was a possible 0. But because of this 44, it's not a 0 in the end. But let's take a look and see what f of 3 is. 3 is over here somewhere. So if I put 3 into this function, oh, not 4, 3, we see that f of 3 is 44. So I have another really nice result out of this synthetic division. The synthetic division gives me the function value. So f of 3, the number that I was dividing in, is equal to that remainder, 44. Okay, very cool. Love synthetic division. Let's do another one. X cubed minus 3x divided by x minus 3. So again, I start with that possible 0. So this time, 3 is a possible 0. So I'm going to divide 3 in. I'm missing a couple of degrees, aren't I? So let me label my degrees. So I need to have degree 3, 2, 1, and 0, a column for each of those. So I do have, no, I want green. So I do have 1x cubed. I don't have any x squared. I have negative 3x's, and I have 0 constants or degree 0. Okay, let's go ahead and move through our synthetic division. As I go down, I add 1 plus nothing is 1. Move up diagonally, I'm multiplying by 3. 1 times 3 is 3. I go down, I add 0 plus 3 is 3. Move up diagonally, just 3 times 3 is 9. 9 minus 3 is 6. Move up diagonally, 6 times 3 is 18. Add those together, and I get 18. Okay, a couple of results here, but first, this is not a 0 because I got a remainder. F of 3 is 18, or at least that's what we think it is. Let's verify that. X cubed minus 3x. X cubed minus 3x. And I want to evaluate that. Oh, I already had f of 3. And f of 3 is, in fact, 18. It is not a 0. We do have a couple of zeros here. If I were to divide these in, I would end up with a remainder 0. But in this case, I had a remainder 18. And it verifies that f of 3 is 18. Okay, so check. We verified that one. But I also want to write this in the form quotient plus remainder over divisor. So my quotient, this was degree 3, which means that this is now degree 2 and an x and a constant plus plus. So our quotient is 1x squared plus 3x plus 6 plus remainder, which is 18, over my original divisor, which is that x minus 3. Okay, and there's that. Finally, I think this is our last one, number 3. So we're going to find a 0, and we want to use synthetic division to verify that it is in fact a 0. So I'm going to go ahead and find a 0 using Desmos. I know that a 0 is the same thing as an x-intercept. So let's put this one in, x cubed plus x squared. See how much I can remember this all at once. X cubed plus x squared. Minus 8x minus 12. Minus 8x minus 12. Okay, there we are. So we've got a couple of zeros. I've got a 0 at 3. Then I have a 0 of multiplicity 2. Take a look at that behavior at negative 2. So I have 2 zeros. So my zeros are 3. That would have come from a factor x minus 3. And 2 negative, which would have come from the factor x plus 2 squared. Let's go ahead and do the 3. In order for it to be a 0, we need the remainder to equal 0. And that would show us that f of 3 is, in fact, 0. So let's go ahead and do this with our long division. My degree, 3, 2, 1, 0. So I don't need any placeholders here. I'm going to divide 3 into my coefficients. So let's just write, oops, I want this guy. Degree 3, 2, 1, 0. Okay, so I've got 1x cubed, 1x squared, negative 8x's, and then negative 12 is the constant. So I go down, I add 1 plus nothing is 1. 1 times 3 is 3. 1 plus 3 is 4. 4 times 3 is 12. Negative 8 plus 12 is 4. 4 times 3 is 12. And sure enough, I have remainder 0. Let's take a look at what the quotient is. This was degree 3, which means that this drops to degree 2. Plus 4x plus 4. So I verified, because of that remainder, I verified that 3 is a 0. Well, we also saw that -2 is a 0. So I can divide -2 in as well. And I could divide -2 in either into my original function, or I can divide it further into the quotient. So I want you to take a look at what we're really doing here. We're starting to divide off things. The x minus 3 went in evenly, which means that x, actually, let me do this in a different color. That means that, so many connections here, my original polynomial could be divided evenly by x minus 3. So this is equal to x minus 3 times something. And that something is my quotient down here. So times x squared plus 4x plus 4, just enough room. So if I wanted to verify that -2 is a 0, I could actually do that into what I had left from the last synthetic division. So let's go ahead and do this into the last one just to get some more practice here. -2 is also a 0. Instead of dividing it into the original function, I'm going to divide it into my quotient. So I've got 1x squared, 4 x's, that's not a negative, 4 x's, and 4 for my constants. My degrees were 2, 1, and 0. Okay, so go through the synthetic division. 1 plus nothing is 1. 1 times -2 is -2. 4 minus 2 is 2. 2 times -2 is -4. I add those together and I get another remainder, 0. So this verifies that -2 is a 0. And it also tells me that x minus 2 divides in evenly. So I can say even further that that polynomial function, x cubed plus x squared minus 8x minus 12, is equal to x minus 3. Well, x minus 2 also went in evenly, times x minus 2 times whatever quotient I've got left here. My quotient actually is, that was degree 2, so this is going to be x, and this is going to be plus 2, plus 2. And I think I wrote this wrong. This should be plus. This should be plus, so get that corrected. -2 comes from a factor of x plus 2. Okay, so x plus 2. And then I can throw my quotient in there as well, x plus 2. Well, what is this? If I write it, this shows me that I've got x minus 3 times x plus 2 squared, and that is in the wrong spot. X plus 2 quantity squared. I've got 3 as a 0, no multiplicity, -2 as a 0 with multiplicity 2. And verifying that with our graph, that's exactly what we see here. Linear behavior at the 0, 3, quadratic behavior here at the 0, -2. We're going to do more with polynomial functions in the next section in terms of synthetic division and zeros, but it's a really, really powerful tool as we're working with polynomial functions.